Standing 5 feet tall, Shaky was driven by 2 motors and had a TV camera and radio link to an off-board computer. It could navigate, keeping track of its position and speed by counting wheel revolutions.
We wanted a system to be able to learn a little bit about its world, make a map, use that map to figure out how to make motion throughout its world, how to move.
Lacking a complex vision system, Shaky's world was a simply painted geometric environment, deliberately making it easier to perform the higher functions of learning and planning. Shaky could perform simple tasks such as moving a block from one place to another. From a general command, Shaky would assess the state of the world around it and deduce what it needed to do to complete the task.
And in fact, it worked very well. You could go in and move the boxes while the robot was performing some plan. It would recognize that things were going wrong, it would replan, and it would figure out what to do again. Just a phenomenal idea.
We put together a component in the area of computer vision, in the area of planning, and we put these together into a system that functioned smoothly, all as one integrated device. I think that was probably the first time that so many different components, so many different parts of artificial intelligence were put together into one system.
Even though Shaky's brain was impressive, spontaneity was not its strong point. Every move took more than an hour to compute, and even then, there was a high chance of failure. Over at Stanford University in the early 70s, they were having problems of a different nature with their robot vehicle, namely trying to keep it under control. The AI lab was experimenting with the famous Stanford Cart, a mobile robot which, unlike Shaky, could see and navigate in any environment.
The cart had on it a television camera, and we illegally used an unused television channel, and we used model airplane type controller to get the information back to the cart.
From 1971 to 1979, AI students like Hans Moravec wrote programs which developed the cart from a dimly aware road hazard to a machine able to track its path from the horizontal shape of the skyline.
You could use it indoors or outdoors. You could move chairs and tables. You didn't need special kinds of objects. It could recognize just about anything. In fact, natural objects worked better with the cart.
The cart had one camera that took a series of 9 images from which it would gauge the distance to an object by using 9 separate coordinates. Its performance, however, still lacked perfection. On a good day in 1979, it could successfully cross a cluttered 30-meter space, but it took 5 hours to do so. The dreams of AI roboticists were constantly pulled back down to earth by the harsh reality of current technology. But upgrades in computer processing power did lead to progress. Flaky, son of Shaky, emerged at SRI in the late 70s. Roving SRI like a distant cousin of R2-D2, Flaky could interpret even vague statements from its master and perform an appropriate action.
I want Leslie to have the bagel. Enter.
I want Leslie to have the bagel. Finished successfully parsing sentence.
The master only said he wanted Leslie to have a bagel. Flaky reasoned he must find her and deliver it.
The idea at that point was that you were trying to make a robot that would essentially be a robotic person. That is, it would have all the capabilities, hopefully, eventually, of a person self-contained within this one box.
Flaky saw through a TV camera eye. Its sonar sensors were hooked up to a map-making program which plotted and stored information.
It's able to move in real time. It builds up its model of the world very quickly, say as it moves down the corridor. It figures out that it's in a corridor, that it hits an opening like a door, that it's supposed to turn in that door, and that it actually does turn into that doorway.
By the late 80s, Flaky was given stereoscopic vision and enhanced speech recognition software. But it was still a far cry from the goal of human equivalent robots envisioned by the pioneers of AI at the dawn of the computer age.
Sign here.
Tobor, the most amazing, the most fantastic creation of man's mind.
Oh, he looks alive.
Throughout the 1950s, 60s, and 70s, popular culture tenaciously held on to the vision of the intelligent robot. But fantasy still far outstripped reality. Mechanical men built during this period, like Swiss engineer Peter Steuer's robot, were little more than sophisticated automatons, close cousins of Electro and Sparko from earlier decades. However, researchers were pursuing the dream of a human-like robot, one arm at a time. In the 1950s, highly dexterous mechanical arms had been developed for handling radioactive isotopes. SAM was built for NASA to operate in radioactive test sites and in outer space. These machines were teleoperated, reacting only to human control. Then scientists at Stanford and MIT coupled this mechanical dexterity with the new advances in artificial intelligence and vision systems. Experimental robots like the Salisbury Hand gave the machines a refined sense of touch, so they could handle small and delicate items. In the early 1970s, several Stanford graduates recognized the potential of these breakthroughs for private industry and formed a company to manufacture and market these intelligent robot arms.
That company had three people, Vic Scheinman, myself, and Bruce Shimano. The company was called Vicarm, which stood for Vic's arm, and we began to build small electric computer-controlled robots for research purposes.
The Vicarm could move with unprecedented precision and reliability. It was capable of repeating a motion with stunning accuracy. The partners wanted to take their invention to the industrial market, essentially giving the Unimate a brain. So like Joe Engelberger before him, Vic Scheinman took his robotic show on the road. Ironically, it was Engelberger who got him in the door, literally at a trade show in Chicago in 1975.
All of a sudden there was this commotion out on the steps, and we asked security to go out there and see what was going on. Well, Vic Scheinman was out there with a briefcase. He'd open up his briefcase and this little robot arm would move around. So we threw him out of the trade show 2 or 3 times.
And he was standing out in front of the show with a robot under his arm, and it was like a Frenchman selling filthy pictures, you know. And I said, "Come on in, Vic, and we'll put a table up at the corner of our booth, and you can start showing people." And all the attention came to Vic's little arm.
Unimation was so impressed that they bought the Vicarm company. General Motors then commissioned them to create a new robot for automobile assembly lines. Together they developed a robot that set an industry standard, the Puma, Programmable Universal Machine for Assembly.
The Puma was an industrial version of the Vicarm technology. It had incorporated into its base an LSI-11 computer, a small microcomputer. It could move to a repeatability of 0.004 of an inch, which is about the thickness of a sheet of paper. That early computer had only 8 kilobytes of memory in it. And I remember my partner, Bruce Shimano, commenting to me that he didn't think he'd ever be able to develop enough software to fill 8 kilobytes of memory.
Unlike the massive hydraulically controlled Unimate, The Puma was a small electric robot.